Okay. Sorry, Jordan and Brock, you missed your 5 minutes of world fame because Melanie didn't have the recorder on yet. That's okay. Everybody does that. Everybody does that.
I didn't record your famous answers.
Okay. All right. Now, everybody that has a computer, Melanie has put up the April star chart and has enlarged it so we can only see part of it. We're looking south. Now, I can't, so you can find it. It's a little to the lower right of dead center, Leo, the lion. And do you see how there's, I call it the backwards question sign. If I point, that won't work, will it? Ah, there you go. Melanie's running the little mouse around.
Yeah.
Another name for it is the sickle. Back in the days before everything was motorized, farmers went out with this sickle and cut down the wheat fields. Imagine that, all by hand. So those are two very famous asterisms, patterns of stars, parts of constellations. Let's see. I think I had another question. Don't go looking at the map now, whoever was supposed to look this up, but it's here. The twins, a famous two stars near each other in the sky, Pollux and Castor. What constellation was the twins in? Did anybody look that up? Well, you can all see it on the map. Somebody? Megan, how about you? It's written sideways, the name of
can you repeat? Okay, what am I looking for? I'm looking for
Pollux and Castor, over like at 3 o'clock roughly.
Okay.
What is the name of the constellation they're in?
Ooh, is that the Archer? No, it's is that the
Twins.
Oh, the twins.
Okay.
Okay, yeah, there we go.
Yes,
Right there.
Mary Lou, the
That's
twins
better. Sorry, yeah, it's so
from
small. There we
ancient
go.
Greek. Okay.
All right.
And then I asked Mary Lou, I think, the difference between double stars. We're going to talk about double stars this time. And there's two kinds. The true double stars called binaries, and the apparent double stars, which are called optical. So Mary Lou, I think you and Jerry looked that up.
Yeah, we did. A real double star is two stars that rotate around a common center of gravity.
Okay.
And there's an example in the handle of the Big Dipper.
Yes, and we'll talk about that a little bit later.
Okay.
And just before you go on with the next one, any of you that have done square dancing, you know there's the call, grab your partner, swing her around. So think of the two people holding hands and pivoting around their hands. So that's the example for a binary star. There's a common center somewhere, not necessarily in the middle. We'll talk about it in a bit, but they rotate around it. What's the other one, Mary Lou?
Jerry had that one. It was
Okay.
optical.
Yes.
Well, tell what the optical star is.
Oh, that's hard to explain. It's just a star that looks like a double star.
But they,
But it's actually two different stars without that don't rotate around a center of gravity.
Okay, they look like they are, but they
It's
aren't.
an optical illusion.
Yeah, they're in the same line of sight. It's like, I don't know, two football players on the field. One may be 100 yards away from the other, but depending on where you're sitting, they look like they're right next to each other, line of sight.
Yeah.
So the ones that astronomers are interested in are the true binaries, and we'll talk about a few of those later. All righty, M44, an open cluster. What is its nickname? Which I really enjoy the nickname. Who had that? Do you have any, Melanie?
I think that might have been mine, and I
think that was Rima had that one.
Oh, Rima, where are you? Your question is up. Okay, she said it was called the Beehive cluster in Cancer. Now, I think I'm going to put my foot in it, and after the program, you can check me out and see if I remembered correctly. I think it was Galileo back in the 1600s with his new telescope he had made. He was not the inventor, but he had heard about it, and so he made his own. And one of the things he spotted in the sky was not just that fuzzy little haze, but a whole cluster of bees, yeah, right, of stars that reminded him of a bunch of bees buzzing around a hive. I think it was Galileo, but you can double check that later. Alrighty, M44. So who was the man? This is like a reminder from a month ago. The man in Paris who came up with that index, M1, M2, M3. Who, does anybody remember who that was? Messier, yes, the Frenchman. So M44 is the beehive. And let's find it here on our map. I think, did I ask anybody how we found it, or was that a general question for everybody? Okay, once again, one of the ways we find when we're new at this, certain stars are bright and we learn where they are and their names first. And then we can make lines here and there and find less bright things. So if we look to Regulus down here in the foot of Leo the line, and then we swing along the ecliptic, this dotted line, the path of the sun, up towards the general area, towards, let's swing off that. We're taking a detour off the highway.
Talking about M44.
Over to, yeah, through
Oh.
44 up towards Pollux and Castor. Now, if you have decent eyesight and a clear night, no moon, no pollution from town, if you, in your mind, draw a line between Regulus, which is easy to see, and the twins that are easy to see, just about halfway, in the middle of a relatively dark sky, no real bright stars there, is that strange upside down Y, which is the constellation Cancer. And right there in the middle of it is the beehive.
Hmm?
And when I first found it a
No,
year ago.
and so she didn't, M44 is the beehive.
Oh, did I say it wrong? M44 is the beehive.
Yeah.
Yeah.
So what
So,
did you say about Andromeda? She didn't mention Andromeda.
No, I know.
okay. When I first found it, I found it with binoculars. I scanned the sky between Regulus and the twins, and then I did it with my binoculars and it popped right out. It's about the size of the moon. Then once I knew where it was, I could see it with just my naked eye. And what it looked like was a little fuzzy blotch in the sky about the size of the moon. And one of the interesting things I think about its history is that the mariners of old, before we had the National Weather Service, which isn't always correct, they would use whether they could see it or not as a forecast of the
She's
weather.
at the library.
Yeah. Because if the weather is really clear, it means it's dry, which means we're not going to have a rainstorm or a late spring snowstorm or bad weather on the sea. But if they couldn't see it, it meant, well, assuming there were no clouds, it meant the skies were hazy because they were humid, which meant moisture in the air, which on our planet usually heralds a storm coming with rain or snow, bad weather. So the beehive was, in the olden days, 100 years to 300 years ago, for the sailors at sea, the weather report, which I like those kind of stories.
Why did they
Okay.
use that as opposed to other?
Because
stars?
that first rises in our skies in the late winter,
Okay.
which in the North Atlantic anyway, usually is a time of bad weather
Okay.
from November over the winter into the early spring. And since it was obvious, you know, it was in the right place at the right time to be the weather forecast for that time of year. All righty. Okay, we're gonna mute you guys for about 10, 15 minutes here while I present today's talk. And Melanie can run her little thing around if we need that. And so who is it just the people that signed in on time? Anybody else come late?
Let's see. Do you know this person? Or who?
Nope, somebody new. Okay,
I think that's it.
okay. Is it Jorge? Somebody new. Hi, Jorge. Whoever you are, wherever you are in the world. All righty. I just want to briefly talk about Leo. And Regulus is the brightest star in Leo. And I was going to have Melanie do this, but she can't have the map as well as type in words. So I'm going to give it to you. As you know, you should have paper and pencil handy. For some reason, and I don't know where this originated, somebody decided they would label the stars from the brightest one in the constellation on down to the dimmest one in the constellation. And they would use the old Greek alphabet. Alpha, beta, gamma, delta, epsilon. So since I can't show it to you, one of your homework assignments is to look up the Greek alphabet, the symbols. Alpha looks like an A. Beta looks like a B. Gamma looks sort of like a Y. Delta, and I wonder if our delta forces use this as a symbol, looks like an apple with a stem coming out of the top. And epsilon looks like a capital E, but you can look those up. And this is one of those 90% rules. For some reason, you're going to look at a constellation and say, well, that's the brightest. Why did they name it beta? I don't know. But in general, when you look up a constellation, and let's look at Regulus in Leo, that's the brightest. And the one down by its tail, the Nobula, I think it's called, is beta. So if you see something that says Regulus, Alpha, Leonis, or Leo, or the whole Latin for Leo, or Greek, whatever it is, Latin, I guess, that tells you that's the brightest star in the constellation. So let's swing up to the Gemini, the twins. Pollux would be the Alpha, and Castor would be the beta. And look at that. They have that opposite, don't they? So that's an example of where they break the rule. You see that little A sign next to Castor?
Oh, yeah.
Yeah. So I don't know why they did that. Unless there is a theory. Sometimes astronomers can go backwards. They know how far the moon was away from the Earth 4 billion years ago, and they know where it'll be in another billion years. But sometimes we can't go backwards. But the suggestion is that because the twins, Pollux and Castor, they think maybe Castor was brighter 4,000, 5,000 years ago. And for some reason, it has faded. Or Pollux has gotten brighter. All right, so maybe if the labeling started a long time ago, maybe Castor was the brighter of the two, and that's why it got the alpha sign. All righty. Make sure I don't miss anything. All righty, we're going to move on to double stars now. And I want you to use your imagination. So Brock, this is especially for you. Young people sometimes have wonderful imaginations. So Brock, we have one sun in our sky, don't we? The sun. It's a star. However, scientists say that, and this isn't somebody, Jerry, why don't you look this up for me over the next 2 weeks and let me know next time. Jupiter is a huge planet. If it was maybe 100 times denser, we would have had 2 suns in our solar system because it would have been dense enough, big enough to get hot enough to start to glow, nuclear reactions. Now that didn't happen here, but if it did, think about how complicated our sky would be sunsets, two of them,
Mm.
2 sunrises. Would they be 12 hours apart? Probably not. Yeah, so it'd be a crazy sky. Alrighty, so let's keep that in mind. We talked about the binary true double stars that rotate around that common center. Now think of the swingers at the square dance. If they're both the same mass, and we won't use weight, that gets us mixed up because weight and mass are not the same. If you go into space, your mass stays the same, but you sure do lose weight. On the moon, hey, that's a great way to go on a diet, right?
Right.
Just go live on the moon. Okay. So if you consider the mass, let's say we have a massive star and a smaller star, but they're binary, they're rotating around each other. That center of the mass is not in the middle. It's closer to the biggie. So you have to think of it that way. And what Mary Lou mentioned a wonderful example that most of us know about. In the handle of the Big Dipper, can we scoot this down and find the Big Dipper? I'm gonna make her mess with the screen now.
Whoops.
Yeah, the other way, so we can see the northern hemisphere. Keep going.
Oh, there's the Big Dipper.
Okay, aha. All righty, here's the Big Dipper right smack in the middle of the clock. See the handle runs off to the left? Right in the middle there is Mizar and Alcor. And if you look really closely, you can tell it's a double star because they have a circle on top of the black sphere. That indicates on a star map, it's a double star. Now, this is an assignment for everybody. And you don't have to tell anybody the answer. It's like your age and your weight. You don't tell us how good your eyesight is. But on a clear night when the moon's not around and you can see to the north, find the Big Dipper, which, by the way, will be upside down for us at this time of year. The Big Dipper pours the water out in the springtime, which is why we have so much rain in the springtime, according to legend. But anyway, find the handle, and in the middle, you should be able to see with your naked eye the 2 stars, one much brighter than the other. I think they're magnitude 2 and 4. The other great one, and maybe Jerry and or somebody with a telescope in the summertime when we have our outdoor star program, but you can look it up on the summer star chart. Alberio, A-L-B-E-R-I-O. It's the head of Cygnus the Swan. And it's one of the most beautiful double stars that we can see with a telescope, a small telescope. You don't need a big fancy one, because one is blue and one is yellow.
Oh.
Yes, and it's real obvious, the blue and the yellow, with a telescope that will separate them. For
Mm.
us with our eyes or binoculars, it looks just like one star.
Mm.
But so we'll see if we can find that in the summer, either with the libraries or with Jerry's telescope. All righty, now let's go back to Castor. Oh, wait, they're still there, Pollux and Castor. If you look up in the sky, Castor is higher than Pollux. Let's see, is that correct for me? Yes, and it's not as bright, but Castor is an amazingly strange star because not only is it a double, the double, 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 there's actually 3 pairs of stars that intricately circle one another in a complicated pattern that equals 6 separate stars, which I never knew until recently. I read a book that had that information in it. Just briefly, the pair A and the pair B are roughly the same size, and they circle fairly close to each other, around and around in doubles. And then C, poor little C, a pair of much smaller stars, and they're way further out, circling around the inner pair. So if you can imagine what our sky would look like if Jupiter was a sun as well as the sun. I think you would need an advanced mathematics education in geometry, three-dimensional whatever, to figure out what would be going on in
Good
the sky
catch.
of some planet around one of those stars, because you'd have 6 stars dancing all over the place. So I think that would be very, very, very interesting. All righty. It's time for our assignments. What time is it? I know,
It
I've lost-
is 1:29.
Okay, good. All righty, ready for, got your pencils and papers, folks? Let me see. Who's I going to give the hardest one to? All right. Brock, are you still with us? Okay,
Yes.
great. Okay, here's what I want you to look up, find out what is a meteor? METEOR. A meteor. And Megan, you still listen, Megan?
Yes, I am.
Okay, what's a meteorite?
All right.
METEORITE. Then Jordan, you're a history buff, right?
Yeah.
All right.
Yeah.
What happened in Alabama, I think in the 30s, when all the stars fell on Alabama? It was such an amazing event that they made a song about it. The night the stars fell on Alabama. So you find out what that was, what happened, etc. All the news reports, people running to church thinking the end of the world had come. So you look that up, the night that the stars fell on Alabama. Okay?
Okay.
All righty. Wait a second. Rima, we'll tell you later. Rima's gonna do the composition of meteors. Right. Meteorites, the composition. Jerry, I want you to find where on Earth is the largest meteorite?
It's pronounced Jared, and where on Earth is the largest meteorite?
Oh, no,
Wait.
there's a Jerry here.
Oh, I'm sorry. There's another Jared.
There's this Jared, but
Oh,
then there's a Jared.
Okay, Jared, you hang on. Okay, never mind. Jared, you answer this one. Where would we find on the Earth the largest meteorite? Okay.
So we have to search it up.
Yeah, research where the biggest one fell to Earth. Where is it? It's still sitting there, I think. I don't think they moved it. All righty. Number 9. Jerry here, Mary Lou's Jerry. Jerry? Are they on?
Yeah.
They can hear.
Yeah, they can hear.
Okay. Where would you go if you wanted to find the most meteorites? Easy to find.
Perseids.
I don't.
No, not in the sky. Meteorites on the
Big
Earth.
shower.
No,
Okay.
on the Earth.
Oh,
If you
Where
were to
on
go,
the Earth?
where do you go to collect meteorites?
Oh, Alfred Station.
Okay,
Um,
and not in the museum. Where do scientists go on expedition to pick them up and bring them back for study? Let me see. What did I forget? Who didn't get a question? Melanie?
Mary Lou.
Who? Mary Lou.
Mary Lou.
Okay. What does a radiant mean? RADIANT in connection with meteor showers. So we're going to find out what's a meteor, what's a meteorite, what's a radiant. Oops. Melanie, you don't have one
I
yet, do
don't
you?
have
Oh,
one.
we'll give this one to Melanie.
Okay.
What is the source of meteor showers? And Jordan's gonna find out what happened down in Alabama. And Rima's doing the composition. And
Jared.
Jared is doing the largest. And Jerry is finding where we go to find them. Alrighty. Then what I want everybody to do, you see, the reason I'm doing this is that next time, let's see, before we meet, there's going to be a meteor shower. called the Lyrids. Lyrid. And it runs. Why didn't I write that down? The peak is going to be on April 22nd. But from a week before to a week after, you'll see more meteors coming down from the sky. But the peak night will be April 22nd. Unfortunately, at 4:30 in the morning. And then there'll be like 18 per hour in dark skies. And where do you look? Let's see.
That's Earth Day.
You look towards the east. And if it's at 4:30, you look fairly high up. So you face where the sun's going to come up and then crane your neck up more than halfway up in the sky. And they'll seem to be coming from there. Now, at dark, 10 o'clock, 11 o'clock, before you go to bed, there'll be a few, but they won't be as many. All righty. So, and let me think. I forget what the moon is doing. I think the moon is coming up around or setting around midnight. So the moon will be up and halfway bright earlier in the night, which means you won't see as many. Okay, question time. Okay. Jared, where do you live? Are they all, you can all talk now.
Who, me?
Yeah, Jared, the newcomer, where do you live?
San Diego.
Oh, are you with Megan in the crowd?
No,
He's my friend, Jared.
He's at the-
Okay.
I'm at-
Gotcha.
I live in the USA.
Yeah.
Wherever.
You know what? You're at the age where everybody says, what's my address? I live at 1 Main Street in big city in the USA, in North America, on the Earth, in the solar system, in the Milky Way galaxy, right?
Yeah.
Yep. Did you ever do that? I remember doing that. Didn't we all do
Yeah.
that? Yeah.
Yeah.
Okay. All right. Anybody have questions about what we went over? All right. So 2 weeks from now at 1 o'clock, we'll be back and hopefully you'll all pay attention to the weather report. Obviously, if it's raining or cloudy, you won't see any meteor showers. So don't wait till the 22nd, maybe a few nights before, go out and see. You younger folks, I know, hate to get up so early in the morning. Us older folks are usually up once in the middle of the night anyway, so we can see it. But anyway, so hopefully you'll see some shooting stars. All right.
Excellent. Thank you,
Okay,
Mary
bye,
Lou.
guys.
I want to stop recording.
Bye.
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 Bye.